Picture this completely ridiculous, yet statistically terrifying scenario. You are casually floating through the vast, dark emptiness of outer space. You are wearing a high-tech, ridiculously expensive astronaut suit. And in your gloved right hand, wrapped carefully in shiny aluminum foil, you are holding a freshly made, warm, delicious, extra garlic sauce shawarma. Life is good. You are about to take the ultimate bite of Middle Eastern street food in zero gravity. But suddenly, you realize you made a terrible navigation mistake. You look down, and right beneath your boots is a massive pitch-black sphere surrounded by a swirling, blinding disk of superheated, glowing gas. Congratulations, my friend. You have officially entered the gravitational trap of a stellar mass black hole. Now, before you start frantically screaming into your space helmet radio, trying to call your mom or ask your space insurance agent if cosmic void accidents are covered under your basic plan, let us break down what a black hole actually is. A black hole is not a giant vacuum cleaner floating in space. It does not actively hunt down innocent astronauts or go around sucking up planets like a vacuuming robot on a living room carpet. A black hole is simply an insane amount of mass packed into an infinitesimally tiny point in space, known as a singularity. Imagine taking our entire planet Earth, with all its massive oceans, tall mountains, heavy cities, 8 billion people, and billions of stray cats, and squishing it down until it fits inside the size of a tiny marble in your pocket. Earth would still have the exact same mass, but its density would be so mind-bogglingly extreme that its gravitational pull at close range would become completely unstoppable. As you and your delicious shawarma begin falling freely toward this ultimate cosmic nightmare, everything feels surprisingly peaceful for a few brief moments. Because you are in freefall, you do not even feel the pull of gravity crushing you yet. You are just gliding gracefully through space. You look at your shawarma. It looks fine. You look at your boots. They look fine. But as you get closer, you cross an invisible, deadly line in space known as the event horizon. The event horizon is the ultimate point of no return in our universe. It is the geographic boundary where the escape velocity required to pull away from the black hole becomes faster than the speed of light itself. And since nothing in our universe can travel faster than light, not even radio signals, high-powered rocket thrusters, or your desperate prayers, once you cross that line, you can never go back. The moment your boots cross the event horizon, your fate is sealed. Even if you had a rocket engine powered by 1 billion nuclear bombs strapped to your back, you could not escape. All paths in space-time inside the event horizon lead directly, inevitably, and mathematically toward the singularity at the center. But long before you even reach the singularity, something truly horrifying, bizarre, and scientifically fascinating starts happening to your body and your lunch. Scientists actually have an official, brilliant, and surprisingly appetizing term for this process. It is called Spaghetification. Yes, you heard that right. Spaghetification. Real, serious astrophysicists in expensive suits actually write that word in heavy peer-reviewed scientific journals. Here is how Spaghetification works, and why it is going to completely ruin your day. Gravity gets exponentially stronger the closer you get to the source of mass. Because your feet are falling toward the black hole slightly ahead of your head, the gravitational pull on your boots is significantly stronger than the gravitational pull on your hair. If you are falling feet first, the black hole begins pulling on your feet with millions of tons of force, while your shoulders and head are experiencing much less pull. At the exact same time, the extreme curvature of space-time starts squeezing your sides inward. The black hole is effectively grabbing you by the head and feet and stretching you like a piece of cheap warm bubble gum, while violently squeezing your waist like a giant invisible trash compactor. You are no longer a normal, nicely proportioned human being. You are rapidly being turned into a human noodle. You become 10 feet tall, then 50 feet tall, then a mile long, stretching thinner and thinner by the millisecond. And what about your shawarma? Well, your shawarma is undergoing the exact same horrific fate right alongside you. The delicious flatbread, the juicy meat, the crispy pickles, and that glorious extra garlic sauce are all getting stretched into long, microscopic atomic threads of shawarma spaghetti. Now, while your body is being stretched into a multi-mile-long human string cheese, something even more mind-bending is happening to time itself. Welcome to Einstein's theory of general relativity, where reality gets so weird that your brain might actually fry before the black hole even touches you. You see, mass and gravity do not just pull on physical objects like rocks, astronauts, or shawarmas. Gravity actively warps, bends, and stretches the very fabric of space-time. The stronger the gravitational field, the slower time ticks relative to the outside universe. Imagine that your buddy Dave is sitting safely in a space shuttle 10 million miles away, watching you fall through a pair of high-powered binoculars. To Dave, watching from a safe distance, something completely impossible appears to happen as you approach the event horizon. As you get closer and closer to that invisible boundary, Dave sees you moving slower and slower and slower. To Dave, your ticking wristwatch slows down to a crawl. Your terrified screaming over the radio drops into a deep, ultra-slow, unintelligible, demonic growl. Right as you reach the exact edge of the event horizon, to Dave's eyes, you appear to freeze in place entirely. You become a frozen, stationary statue floating in space for eternity. Not only that, but the light reflected off your spacesuit gets stretched by the extreme gravity into longer, redder wavelengths, a process known as gravitational redshift. Dave watches you turn from a bright, colorful astronaut into a dim, reddish ghost, until you fade into complete darkness and disappear from his view forever. To Dave, you never actually fell into the black hole. You just hovered on the edge, turned red, and faded out like a dying television screen. But what do you experience as you fall? Well, from your perspective, time inside your own frame of reference ticks totally normally. 1 second feels like 1 second. Your watch ticks fine. Your heart is beating at 200 beats per minute out of absolute panic, and your shawarma is still stretching at normal speed. But when you look back over your shoulder at the universe you just left behind, you see something straight out of a sci-fi fever dream. Because time is moving insanely fast in the outside world relative to you, as you look back out into space, you literally watch the entire future history of the cosmos play out in fast forward, like a hyperspeed movie. In just a few milliseconds of your subjective time, you see stars aging, exploding into brilliant supernovas, and dying. You see whole galaxies collision dancing with each other across billions of years. You might literally watch the entire lifetime of the universe, from the birth of new solar systems to the ultimate heat-death of cosmos, play out right in front of your eyes before you cross the threshold. You are literally watching eternity pass by while holding a stretched-out atomic noodle of garlic shawarma. But hold on tight, because we have not even addressed the biggest debate in modern theoretical physics yet. What actually happens the millisecond you hit the event horizon? For decades, classical physics told us that crossing the event horizon is totally smooth. You would not even feel a physical wall or bump. You would just float right through the invisible boundary like a ghost walking through a doorway, oblivious to the fact that you can never go back. But in 2012, a group of brilliant theoretical physicists proposed a radical, terrifying new theory that completely shocked the scientific community. They called it the black hole firewall paradox. According to quantum mechanics, the event horizon might not be a smooth, peaceful doorway at all. Instead, quantum entanglement effects could create a literal, blistering wall of pure, high-energy density sitting right on the edge of the boundary. A literal wall of infinite fire. If the firewall theory is correct, the moment your boots touch the event horizon, you and your shawarma do not get to slowly stretch out into noodles inside. Instead, you instantly slam into an invisible furnace of ultimate destruction, getting vaporized into pure thermal energy in less than a microsecond. 1 millisecond, you are an astronaut with lunch, and the next millisecond, you are just a flash of hot gamma rays radiating into the void. But let us assume for a moment that the firewall theory is wrong. Classical physics holds true, and you somehow survive spaghettification long enough to fall past the event horizon in one piece. What lies at the absolute bottom of this cosmic trap? You are now tumbling deeper and deeper into the dark abyss. Up above you, the outside universe shrinks into a tiny, bright ring of light, like looking up from the bottom of a deep well, until it pinches shut into absolute pitch-black darkness. Down below you, well, there is no down anymore. Inside a black hole, space and time literally swap places. Moving forward in space becomes mathematically identical to moving forward in time. You cannot avoid the center of a black hole for the exact same reason you cannot avoid tomorrow. At the very center of the black hole lies the Singularity, a point of infinite density, infinite gravity, and zero volume, where all known laws of physics completely shatter into a million pieces. Einstein's equations start throwing divide by zero errors. Quantum mechanics and general relativity start screaming at each other like an angry married couple. In the final microsecond before you hit the Singularity, the gravitational tidal forces become so insanely powerful that they break the electromagnetic bonds holding your molecules together. Your body is no longer made of cells or organs. Your shawarma is no longer made of protein, carbohydrates, or garlic sauce. You and your lunch are ripped apart into individual atoms. Then those individual atoms are ripped apart into protons, neutrons, and electrons. And then those subatomic particles are crushed into pure, fundamental energy, merging permanently with the Singularity itself. You are now officially part of the black hole. Your mass, along with the mass of your extra garlic shawarma, has just added to the total gravitational footprint of the black hole in our universe. But wait, the story does not end there. Because legendary physicist Stephen Hawking proved that black holes are not completely permanent eternal vaults. Through a mind-bending quantum process known as Hawking radiation, black holes slowly, continuously leak tiny particles of energy back into space over trillions upon trillions of years. Over an unfathomably long period of time, long after every single star in our galaxy has burned out and died, the black hole will slowly evaporate, getting smaller and smaller until it vanishes in a final, brilliant, tiny burst of radiation. That means that billions of trillions of years from now, the fundamental energy that once made up your body, your spacesuit, and your delicious street food will finally be released back into the cosmic void. You and your shawarma will literally become part of the background stardust of a brand new universe. So, what is the ultimate takeaway from this horrifying, noodle-stretching journey into the abyss? First, if you are ever floating in zero gravity near a mysterious, dark void, keep a very safe distance of at least a couple light years. Second, if you start stretching into a 50-foot-long spaghetti stick, try to enjoy the fast-forward view of the entire history of time before you get vaporized. And most importantly, always finish your shawarma before you step out into deep space. Because cold garlic sauce stretched out into atomic threads across an event horizon is just a terrible waste of a great meal. If you enjoyed this crazy trip into quantum mechanics, black holes, and street food physics, smash that like button, subscribe to Cosmic Clueless, and leave a comment telling me what food you would take with you into a black hole. Stay curious, keep your spacesuit tight, and I will see you in the next episode, humans.